yeah. Uh, তোমাদের এর তোমাদের এরপরে কি ক্লাস আছে? একজন বলো।
নাই স্যার।
আচ্ছা, তোমরা কি চাও আমি আজকে 2টা ক্লাস নিয়ে শেষ করে দিব, তাহলে আর পরের কালকের ক্লাসটা দরকার হবে না?
জি স্যার।
শেষ
সবাই
করে
রাজি?
দেন।
সবাই রাজি? আচ্ছা, তাহলে তোমাদেরকে আমার হয়তো আধা ঘন্টা সময় একটু বেশি দিতে হবে, তাহলে হয়ে যাবে। ঠিক আছে, যেহেতু তোমাদের ক্লাস নাই, আমি এটা শেষ করে দিচ্ছি। সরে যাবে। So, okay, plant disease forecasting. It's the second lecture. We discussed on the concept and significance of plant disease forecasting and the factors, epidemiological factors. We studied that under epidemiology, also under plant disease forecasting, and what kind of information you require or the preconditions for forecasting, and then empirical method and the fundamental method of data collection. Today we'll be discussing on different forecasting methods, models, and outline various steps in the forecasting and the functions and responsibilities of different organizations, including BAU and other research organizations. How could they help in making forecasting system work? What is a model? In general sense, a model is a simplistic representation or abstraction, you could say, is the real world system. In the real world, many things, many factors work together, interacting together to make one outcome. So in a model, you show which outcomes, which factors or which events or which things impact on what strength to make this outcome happen. For example, if disease is the outcome is equal to what? Host factors plus pathogen factors plus environmental factors. So these are the broad categories of factors. There will be many different parameters under host, like we already discussed that on the host types, host resistance, so many things. Under pathogen factors, we know that. Under environment, there are so many factors. So disease is the final output of interacting of all the factors. You might say, when you say interaction, rather than putting plus, you could say multiply here. So you would say disease is the product of the
আসসালামু আলাইকুম
factors.
স্যার। স্যার আসসালামু আলাইকুম স্যার। ওই একটা 30-এ ক্লাস ছিল স্যার, নামাজও একটা 30-এ জামাত, তাই নামাজে ছিলাম স্যার, রোল কল তো হয়ে গেছে।
ওকে, পরে 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 তুমি লাস্টে দিও।
জি স্যার।
ঠিক আছে, তোমার ক্লাস যেহেতু 1:30টায়, তুমি নামাজ আগে পড়বা অথবা পরে পড়বা, বুঝলে? অন্যদের সাথে জামাত পড়বা। ইউনিভার্সিটিতে সকাল সোয়া 7টায়, সোয়া 1টায় জামাত আমার।
এলাকায় তো স্যার, এলাকায় 1:30টায় হয়।
হ্যাঁ, ওকে, ঠিক আছে। এখন লেটস কাম হিয়ার and then H, P, and E. H is the host factors, pathogen factor, and environmental factors. So this is the simplistic representation of, so this is the model. And then through research, you have to find out which particular host factors are impacting in particular disease. more than others. So this is the way you find the research, because you cannot study hundreds of different factors together for every disease. So you have to pinpoint which particular factors are important for one disease. It may not be important for other disease. This is and then finally you come up with, for example, X equal to, for example, 1 or P or K, whatever the constant is, K A plus LB plus NC, something like this. So you may come up to 3 or 4 factors that are impacting more than many other factors. So this will be obviously different for different diseases. So this is what you have to come out with all these different works under FPR forecasting system. So this is the modeling things. So this is the mathematical model or computational tool that integrates data on disease, which I just discussed, and then predict the outcome of disease outbreak, and then inform decision on disease management strategies. So bases or principles of forecasting model. What are the bases of forecasting model? So basically, when I just discussed 3 factors, again, always I'm talking about these 3 factors, but depending on the type of the pathogen, we focus more on one factor than others. That simplify your thinking. So forecasting based on abundance of inocula for some diseases, you put more focus on abundance of inocula so you put more focus on abundance of inocula, primary inocula. So you predict the disease outbreaks through monitor or assess the presence or abundance of primary inocula. So you check the soil, if it is on the soil, that how much inocula present, and then you can forecast, because this may not be important, like other factors may not be very important here. So here, like this is an example here. So when the temperature, when the temperature in January goes above normal, the disease is expected to appear in the seedbed in the following seasons. So you can check the temperature in January, then you expect, if the temperature goes above, then there will be a disease higher inoculum in the seedbed or in the tobacco here. This is one example here, and that will make disease epidemic in the next season, the following season, because you take these seedlings to grow in the main bed, and that carry over your pathogenic inoculum in the bed. So through temperature monitoring, you may say that. So again, temperature based on inocula, for example, some soil-borne inocula. Again, I say these are monocyclic pathogen. For the monocyclic pathogen, they remain in the soil, and by checking the amount of inocula, by determining the amount of inocula in your soil, you may understand by the epidemiological graph X equal to QRT, and then you can forecast that there will be a disease problem. But this is not a very big deal for because the monocyclic pathogen is the like epidemic goes for polytic epidemic. So real-time temperature, you don't probably need to see the real-time temperature here. These are more of the inoculum. That depends more on the initial inoculum rather than the temperature and weather. Even if these are two are important, but not as important as the amount of inoculum. Because whatever the temperature is, there will be disease anyway. And based on secondary infection cycles, these are the lead bladder potato, blah, blah, blah. These are the polycyclic pathogen. You would look for the pathogen dispersal. Pathogen dispersal that I show you some of the, this here. So pathogen dispersal, you check the pathogen dispersal or pathogen abundance in the field. You may construct or you may establish you may put a spore trap around the field, not one, there could be many spore trap around the field to capture the amount of spore inocula on the air. So through this, you can estimate would there be a disease likely in in this season or not, because these inocular spores are airborne. You can easily trap the spore trap. Show the spore trap here. The spore trap is a device. It's a very simple organization here. Spore trap, a kind of glass slide with the sticky substance in the here. So the basic thing is you keep this sticky substance, the slides on the air, and letting the spore deposits on the sticky thing, and based on the amount of time or how long you keep on the air, and then bring that out, take that out, and then estimate the volume or number of the inocular present in the sticky substances time and again. So this is the simple organizations, but to make things easier, otherwise you would put a stick like this, like a selfie stick. You can mount that stick and then mount it on the plot. That's the simple one. But to make things easier, you can make things somewhat sophisticated organization here, like a cup type of things here. So that the amount of volume of air goes through it, and then your sticky slide may be inside. As the air goes through it, it touches the slides, and then the sum of the spore, if the spore will stick on the wall of your sticky trap, and then you can take the slide out and then estimate either under the microscope, or maybe you can go for further analysis in the lab. So this is the simple organization. Maybe you wanted to check what is the spore in the morning, what is the amount of spore in the afternoon, at the night, and then at the seasonal, the diurnal variation here, the day length, variation due to day and night, or even weeks, how long it varies. If you see, okay, a number of inoculum is changing every day, it's getting higher and higher, the likely that there will be a disease coming up very soon. So this is the one we could do, and this is in practice. So let's see. Let me show you a little bit of here. I already discussed, but let's see if there is anything I can show you. There is probably, yes. Why is this? Sorry, taking a moment to find out something here. Look carefully this one. So this is the cup here. Do you see the slide, by the way? The movie things here. Just confirm someone. This is fine. Just say yes or no. Do you see this?
Yes, sir.
Okay. So look at this is the cup shape. So through it, they were suck the air. This one. This
Heute wird die elektrische Sporenfalle an der WSL Birmensdorf geleert. Diese filtert Pilzsporen und andere Partikel aus der Umgebungsluft.
this particular researcher, sorry, the researcher is mounting
Heute wird die elektrische Sporenfalle an der
the
WSL
spore
Birmensdorf
trap
geleert.
around the field.
Sporen
Oh, I'm just rather than again, sorry.
Heute wird die elektrische Sporenfalle an der WSL Birmensdorf geleert. Diese filtert Pilzsporen und andere Partikel der Umgebungsluft.
So she's constructing the little like pods here. So just kind of to keep it standing here. And this is in the forest. They're working research in the forest. How much amount of for around? But it could that around field to see to observe the amount of spore buildup. I said this one of the okay, it's not very sophisticated here. It could be even much more sophisticated using your computer and other things aligned with that. So it can estimate the time with the computer, that the computer will and then take a read, and then there will be again modeling same.
Unter der Haube befindet sich ein Ventilator.
So inside it, they're showing what is inside this spore trap. It's somewhat more complicated things here. So the little more here. Let's see.
Ein Metallrohr und ein
Ah, look at the bottom here. So there are some tubes. So you would expect that the slide will drop on the tube if there are, rather than the one I just said, because their objective is different. There are the spore, they live it on the tube, and then the lab they're doing researches and things. So this is how there are many different variants could be there, but basic thing for epidemiology is there might be a spore trap you could mount around the field to monitor, to assess the real time how much inoculum is there. Then you can put into the graph and say how is it progressing. Again, the disease progress curve. If it is going like this, you might expect the disease is coming, or if it's just going like small development, you might not expect the disease is coming or something, or this might even be like time wavy things, depending on how it's doing. So depending on the disease progress curve, you can easily say, no, it's not yet the time, or load is not thing there. So yeah. And then there are in other cases, and mostly this is the case in forecasting, we base mainly on the weather. We could, but we don't really focus on the amount of inoculum, rather than just weather based on our model, which factors are important. So we might see only single factors, whatever the other factors are important, and then that would be this epidemic, and then you focus on, okay, why not, rather than just depending on the weather forecast from data from weather when put then around the real time observable and the real time the data in the field, and through which you can, because you keep all other factors of epidemic fixed, and then as if they're good enough for the disease, you're only waiting for the weather to come to a congenial stage for the buildup of epidemic. So we have to take it for granted that the most susceptible pathogen is virulent, everything is good for the disease, only is the weather. If the weather is congenial, there will be epidemic. Then you just look into the weather and then put in the graph, and then there will be disease. Even if you don't see any disease in the field, maybe you warn the farmer that might be a disease. So I'm not saying the bases are you depend on these or that, or they could come together saying you're efficient or precise, accurate to predict that. And the basis of forecasting, I think this is the weather. So you either check the weather in the standing crop, in case of potato lead blight, this is in the field, you check the weather. So in some other cases, because in that case, not only the weather, maybe the inoculum is also important. That's why they say intercrop. I think I should write the word intercrop rather than intercrop, because there is a thing like intercropping. So we have the concept of intercropping. This is not, I didn't write the word in that concept. Intercropping is somewhat here like, what did you do before you going to the crop? So interval period between the crop, that's what I meant here. So intercrop is between the cropping in between, so cyclic order. So if the crop, the weather before you cultivate the crop or in between two crops are favorable for some pathogen, so they will grow, the spore and grow, and as soon as you grow the crop, then you will see the epidemic. So the reason is this not only weather and during the crop stage that will impact, but the weather before the crop during the interval period that will impact, because that will make the inoculum build up, and then they'll be able to cause disease. I think it's mostly for the monocyclic pathogen is mostly the thing here. And then forecasting based on critical weather, in this case, critical growth stage of the crop. In this case, focus, obviously the weather is good, weather is important, and then pathogen is important, but mostly is the crop vulnerable stage of the crop you have to take into account. Most is the, for example, Fusarium head blight or panicle blast of rice. So you take more focus on particular growth rather than checking the weather, checking the inoculum throughout the growth season or before the growth season or after the growth season or intercrop. We don't focus on that because of other reasons. Just look into the weather just before panicle initiation, because these are much more critical for the crop for this against that pathogen. So this is how it goes. So again, I say that they are not mutually exclusive. It's not very distinct. You might, if you have resources, if you have the logistics, you could go for all different approaches, all different types base you apply to get the prediction more accurate. And then come into the types of model here. So based on there could be many different kinds of model here. Forecasting model is a simplistic, rather than doing whole lot of data analysis things comes through knowledge, historical events, and the epidemiological knowledge of the researcher or plant pathologist. So, for example, it utilizes the predefined rules. We set the rules through some kind of research, empirical or any experimental research, but mainly based on expert knowledge and experiences rather than doing a whole lot of algorithm here. So, for example, in England, for potato, they say if the temperature goes minimum temperature here and the relative humidity is 70%, go for forecasting. There will be disease. That makes things simple. And Dutch model, similar of the things, they have 4 things come together, they will forecast for the disease, for potato lead blight, the same here. And then the similar kind of model they have developed. This has been developed many long time ago when even people didn't think about the statistical analysis and things. So there are problems associated with that, you can guess, because they based on simplistic assumptions, lack of spatial temporal resolution, because not every places are same. So lack of mechanistic understanding, how does it work? They don't know. They said extrapolate it to our situation. So limited validation and evaluation, and user interpretability is lack of user interpretability. So these are some of the lackings of this model. And then comes the statistical model here. Then what you do is historical. You bring out the history, bring all the historical data, and then historical disease data, and then environmental data. Go to the field or go to the literature, or maybe weather stations, get the 30 years data. And if you have someone trying to ask question. Okay, so you then do statistical analysis and find a correlation, like regression analysis, correlation analysis, path analysis to predict the outcome. And then in other case, this is not actually the forecasting. You obviously need the forecasting to come in statistical model, but statistical, rather than getting whole lot of data here, so they mainly work to understand the mechanistic understanding between the disease and particular factors of epidemic. For example, you simplified all different things through statistics, and then maybe you use the mathematical models, like X equal to QRT, the model we have used in the epidemics, and then you simplified it. And also you try to understand how pathogenic reproduction, transmission, and other pathogenic factors impact the disease. So it's more of the upstream analysis before going to the forecasting system. So it's not necessarily discrete. Again, statistical and mathematical are not distinct, they work together. Even the statistical model go in the umbrella of mathematical model. So these mathematical model are based on principles of epidemiology. And what happens here, mainly you look into the impact of one particular factors on the disease, or 2 particular factors on the disease, rather than getting whole lot of data from the real field and getting the correlation and regression analysis. So researcher would theoretically go for both to forecast the disease. So this is more of a data focused, this is more of a mathematical modeling focused. So historical data, again, the same way in the epidemiology, we said that here is the data, we see the statistical rigor here rather than mathematical integration calculus. So there's not much difference here. Okay. And then computer simulation model. This is an important device now. Computer has, changed the way we think the data could be handled, because we have the power now. We have immense power now handling all the different data. So this has become very, very convenient, rather than just thinking statistical and mathematical work together now, and putting everything in the computer. That will give you the real impact of all the factors and the interactions on the disease. So this is the put all the different variables on the epidemic in the computer. And then the computer not only give the spread and disease severity, but it also will tell you what is the final crop and economic losses. So this is way advanced than just only forecasting the disease. They will tell you, okay, that will be the amount of disease, and that will be a loss. And economically, would you go for forecasting or not? So would you go for controlling measures or not? So this is the computer simulation model. It's more of a complex things, but researcher has to work diligently to find out the real equation here. And then computer simulation model is mainly based on machine learning. We have various languages and packages and statistical platform we use. We use R platform, R statistical software. There are many packages in R. We use Python language. There are many different kinds of language. Python based language here. And then there are maybe other kind of languages. The computer scientists will tell you that what language would be helpful. So the basic thing is the big data. We call it big data analysis, the bigger data handling and analysis. So we use the software, machine learning software. So, and also ensemble model is basically the models of the model, model of the models, model of the models. So to combine all the different models, for example, you develop a model for lead bladder potato, someone else has developed a lead bladder potato model based on a little bit different factors, someone similar crop, similar disease, but they tried their own way. So computer would, okay, combine all this model, let's see more accurate prediction. How does that sound? So yeah, so computer simulation model has been developed, obviously, starting from the developed country like USA, lead black potato, they develop, blister blight of tea, rice blast. India has rice blast in the forecasting system based on the computer simulation model. So the computer simulation, they get some kind of data from the field, and with this data, and then with the previous data, all this data they just examine, and then they predict, so there will be disease, they simulate. And then there are name of some of the model here in worldwide, not worldwide, in many different countries, they have been developed. Epidem is the model developed for early blighted potato. Tomcast, it's tomato cast, I don't know, forecast something. So they say early blighted tomato here. It's a blight cast, lead blighted potato. These are some nickname. You can put any name, but just put the name here. So this is the system, forecasting system. So for lead blighted potato here. And then GeoPotato, this is lead blighted potato. This is the one recently developed for Bangladesh potato lead blight. I'll be showing you in a minute here. So GeoPotato here. There are many forecasting models, many examples, and many different names. I can ask you maybe 2 or 5 names. Just memorize some of the names, so you know they are there. They are there. So epidemic models here. So you just, it is the name you gave it, or someone scientist who developed it just to give the name. The forecasting models based on all the different data, all the different process. So now we got the learning outcome here that we can explain different forecasting model, rule-based, mathematical, statistical model, just a little bit of discussion on that. And then here you go. And I wanna go to my next slide for the another lecture, forecasting here. So let me start over again. I'm not gonna here. So here, so today in this lecture, I have stated you should be able to outline some steps involved in developing the model, real kind of thing here, and then what are the key responsibilities of DAE and BAO, this kind of organization, to help you out to make the disease forecasting model. So let's see the steps in disease forecasting model. What are the main steps you go through? Basically, you know that, just you can think, you can write yourself what would be the steps. First is the define the purpose, define the objectives or goals or aims, objectives of crop, and then which crop, and then which disease, and what regions. So you need this to build the purpose, because you're putting your money is not gonna waste. So you have to be specify which you're putting your money to develop them, because a lot of money will be involved here for research and development. The purpose, after the purpose, you go for development, and your purpose will tell you what activity you would need to develop the model. So it is the main step here, the development. A lot of activity on the part of the researcher. They would get the data, they would do a lot of statistics and computer simulations to find out the correlation of any factors with the occurrence of that particular disease, and then the model will be developed. And then once they develop, you need to fine tune and validate. So you develop the model from data and develop the model, and then see how does it work in the field, in the real field. Does it really work, and what precision, what percentage of the prediction is true? Then you try to, okay, wait, maybe you do a validation in your own real experiment, on experiment, control experiment, or maybe you go to the real field. And then finally you implement in the field. So, okay, now we say our model is robust. It can predict the occurrence of disease very quickly and precisely. But still, if your government and then policymakers will take your forecasting model, and they will implement the model to save the farmers for their crops damage. And then you get again the feedback from the farmers or from the users that or from the government that it's not working or what happens, what percent of the precision there, the better, all the feedback, and then you validate again and fine tune it again. So it's a continuous process. So it continues in like a version 1, version 2, version 3, as the same way you use the apps, the developer of the apps, the changes is in real time and again. They ask you to, okay, install it and then update the version. So there will be many different versions out there. It could be an app. Okay, so I'm talking a little bit on the GeoPotato here. GeoPotato here. The GeoPotato, how big data gives Bangladesh potato farmers a new tool in the fight against lead blight. So lead blight, is a very catastrophic occurrence. I show you one video here. Not sure why it's not coming. Should come up. So the short movie tells you everything, that how was it developed, what things involved here. So let's look a little bit more on here. So what did they do is, what are they doing here is they're getting the satellite data from the satellites, crop growth data, and putting that in the crop growth model. Every growth may have many different kind of model here. So including the disease model or epidemiological model here means all the equations, putting everything on the equation here. And then they're also getting this forecasted weather from the satellite, and then also real-time data from the field. So that combines everything, and by computer simulations, they would provide the suggestions to the farmers whether you should go for fungicide application now, and when, and what kind of fungicide is there. So this is how basically it works. So who are the partner developers? So Wageningen University in Netherlands, and some Bangladeshi information services, AIS, for many different other private and public organizations. They work collaboratively to bring this into the surface. So now it is okay. So now it is how the information technology and then information and communication technology and data science could help that we couldn't think like 50 years before, the power we have now using the AI and image analysis, artificial intelligence, and geographical information systems, and IT. So all these things now have made our life much easier than ever before, and that is going to evolve, definitely going to evolve, rapidly and quickly and continuously. You'd expect the way we think now, maybe 20 years after that, the way they have revolutionary changed. So that's the That's the practicality. That's the real scenario. So remote sensing, sensor network, data analytics, and mobile operation, and GIS, everything all are the computer engineers and statistical modelers, and everyone should come together to work like a network. They work together to make this as a real solution on this forecasting. So we need help, everyone. There is no such thing nowadays is isolation. Everyone come together to bring solution to one problem, because problem have not been created by one or two factors. Problem is the product of many factors. So the solution should include the power of every different disciplines to make it happen. That's the way you should think. So there has been here, and then there are some other and then forecasting system people have tried to develop. This couldn't have been developed in the way that geopolitical has been developed, but this is the main. But there have been here and there sporadic researches going on, epidemiological study in Bangladesh. Not Bangladesh, is somewhat lagging. This is not on their side. The lack on their side, lacking other challenges because interacted together to make it complicated.
স্যার
Mhm.
স্যার আমরা যে একটা কোশ্চেন ছিল স্যার, জিও পটাটোর ওখানে একটা কোশ্চেন ছিল
Of course.
স্যার। ওখানে যে আমাদের কাছে যে ইমেজটা আসবে সেটা কি হচ্ছে স্যাটেলাইট ইমেজ? সেই ইমেজটা হচ্ছে মেইনলি হচ্ছে যে ল্যান্ডের যে কাস্ট করবে, সেইটা যদি আমাদের রিয়েল সাথে যদি ম্যাচ করে বা এরকম কিছু ওই জায়গাতে কি বলা হয়েছে স্যার? ওখানে অ্যালার্ট
No. The thing is, you as a user of the forecasting system, you will get just the notification of in your SMS. Let me show you here. All these things. This is the background of the farmers will just get the message like that. প্রিয় চাষী ভাই, বর্তমানে আবহাওয়া নতুন গজানো চারায় আলুর মরক রোগের জন্য খুবই উপযোগী। আপনি যদি গত 26 ডিসেম্বর মঙ্গলবার থেকে আজ পর্যন্ত কোনো ছত্রাকনাশক স্প্রে করে না থাকেন, তবে আগামী 2 জানুয়ারি মঙ্গলবার এর আগে সঠিক নিয়মে সঠিক পরিমাণে মরক রোগ প্রতিরোধী ছত্রাকনাশক স্প্রে করেন। That's the simple message will go to the farmer's mobile phone. The one I just said in the movie is that how that work in the background. Farmers don't have to worry about that. So for the farmers, the end users just use this. Was it your question or your question was different?
No, sir, it was my question.
It was a question. So farmers don't have to think about the image satellite things. These are already developed. These are continuously satellites are getting the images, and the computer science, the labs are processing these images in real time. They're making they're getting the weather data in real time, and they're making the equation, disease progress curve, everything. And when at the time they found, yes, there will be, and at that point they'll send the message to the farmers, be alert.
তাহলে কি এক্ষেত্রে হচ্ছে কোন ধরনের সকল ফার্মারদের particular
Yeah, that I'm saying, yeah, exactly. It is the farmers had to register. It's the same way you install apps in your phone. If you don't have the apps, you don't get anything, right?
Yes,
So
sir.
you have to install. So here it's not an app. I don't know if this is an app, but it's something you have to register. You have to pay them some money.
Okay,
So
sir.
it's commercially based. So the farmers had to register that I wanna take this service. So okay, you wanna take service, give me some money. They will, and then you get the pack this into their system. And I'm not sure that government would subsidy for the farmers. Could be. I don't know how does operationally it works in the field. So I think you got the idea.
Yes, sir. Thank you, sir.
Not a problem. I appreciate you asking me the question. No one asked me question. As if everyone knows everything, I'm just surfacing here. Yeah, okay. So that critical thing I missed out. And other classes I told that, but in these classes I kind of missed that things here. So okay, the thing is the message, what kind of message would you give to the farmers? Is the fungicide, the time, and these things, the crucial information here you give to the farmers with the fungicide message. So how would you go for messaging? Nowadays, in many different way. It could be television, it could be radio, it could be mobile phone. Now the crucial device, you know, how effective is that now? Very good, very nice. And the internet, everything. So this is the thing here. It's here, this kind of message you will find as a farmer. And roles of DAE, I believe that you can explain much more better way than I could here. The roles of DAE. You know what is DAE? Someone tell me what is DAE?
Sir, Department of Agricultural Extension.
Okay, good. What is this? Is it a university or what?
স্যার এটা হচ্ছে একটা ডিপার্টমেন্ট যেখানে হচ্ছে কৃষি রিলেটেড বিভিন্ন ইনফরমেশন প্রদান করা হয় ফার্মার্সদের বা মাঠ পর্যায়ে বিভিন্ন ধরনের হচ্ছে ইনফরমেশন।
Is it a government or non-government organization?
স্যার দিস ইজ গভর্নমেন্ট অর্গানাইজেশন।
Okay, so you have the idea that the DAE is the one of I guess is the biggest organization in Bangladesh, government organization. So most of our graduates, including you, could also do your work in some point of time. So DAE is very effective organization in Bangladesh, working closely with farmers. So they could do a lot of work on making the forecasting effective. And then how about what is BAU? No one knows what is BAU. Then they could do a lot of things. So teaching, I didn't put that here. And teaching, you can say teaching, research, and survey. A lot of university, a lot of things. Research institution, they could do a lot of things. We are doing some research here, but we have challenges. So what are the challenges? Many challenges. One could be policy related challenges. Why not, a lot of challenges. I don't have any energy to talk much. So if you think carefully and critically, you can find a lot of many challenges for the why not forecast developed for some other important diseases in Bangladesh. They have developed, they have not been effective in the real field. Maybe problem and socioeconomic factors, pesticide resistant, infrastructure challenges, farmers adoption, research connaissance, so many things here. So by this, I think we already finished that up here. And then this could be sample questions. I already sent it to you. And then, yeah, we discussed that in 4.3 classes. These are some of the readings. I know you don't get there, but maybe in the Google, most of the literature you find in the Google, you can read if you like. So recently published 2023. So many of the information I got from there. That's I try to update the things in my teaching. Always I try to read in real time and then update the thing. Like this one I recently published just few months ago, and this one published few months ago. I keep tracking of new publication on that, and always new thing here. All the books to get the old concepts but newer is maybe some are much more great. Any question, please? So if you don't have any questions, huh?
স্যার স্ট্যাটিস্টিক্যাল মডেল আর ম্যাথমেটিক্যাল মডেলস এই দুইটা যদি
Hmm.
আরেক বলতেন।
That's a difficult question. So statistical model is mainly, as we said, in case of process of data collection. One is database, another is the process-based methods. In case of statistics, you get the real data from the field and historical data, like 30 years before, or 40 years before, 20 years before, 5 years before, all the data in the field. And then you try to correlate with weather data and previous field data and try to find out the equation from the disease versus the with the parameters. So in case of mathematical model, so you have your own mathematical model developed through own controlled experiments. For example, x equal to qrt. So you make the graph, and then you develop the mathematical model using integration equation. So through this model, you have developed LED light. In real time, simulate the model and in experiment in the field and see, does that model fit into your data mathematically? How fit is that? They are not discrete statistical and mathematical model. They may work together. Statistical model is the more of a data driven, and mathematical model of a more of a finding the factors of 1 or 2 or 3 factors to see whether that impact disease epidemic by controlled research trial or by maybe data from research. So as I say, there's no real there. So obviously nowadays, because we use computer simulation here, so all putting together in the computers, mostly is the statistical analysis and the computer simulation rather than mathematical equation. Long ago, people would think of much of the mathematical equation. Nowadays, people would be more focused on the statistical rigors. That's the thing, but not very real difference. It's very hard to find section between two, find the section between two. That's it. Anything else? So if nothing else in your mind, I would rather drop it here now. And if you have any question or anything, you may knock me or come to my office and in your free time. Discuss about any particular topic.
স্যার
Huh?
অ্যাটেন্ডেন্সটা লাস্টে বললেন 103
Riyadh, what section? This section? B section.
জি স্যার
So this section 1,
স্যার আমি স্যার মিস করেছি স্যার নামাজের জন্য
1.
স্যার 2622135
স্যার 2
No, no,
স্যার
135.
151
135 আছে না কি বলছিল?
ইয়েস স্যার
3 স্যার
51
135.
ইয়েস স্যার
103
107
3.
স্যার
151
103. তো এখন সবাই বললে তো হবে না, আমি তোমাদের জন্য অনেকক্ষণ বসেছিলাম।
স্যার 107
কে 103 কে
জি স্যার নামাজ বলেছিলাম আপনাকে
103 কে
জি স্যার 103
095
তুমি তো সবসময় অ্যাবসেন্ট দেখা যায়, তোমাকে তো আমি এখানে দিতে পারি না। হ্যাঁ, তুমি তো রেগুলার অ্যাবসেন্ট।
স্যার গতদিনে ক্লাস করলাম
104
না না না,
095
স্যার এদারা কথা বলিও না, ডোন্ট টক মাচ। আমি একটার সাথে কথা বলছি, তারাই বলো শুধু। শেখ
স্যার 1
রিয়াদ উদ্দিন কে?
জি স্যার
তুমি তো
লাস্ট
অনেক সময় অ্যাবসেন্ট।
ফার্স্ট উইক অ্যাবসেন্ট ছিলাম স্যার, গতদিনও তো ক্লাস করলাম স্যার অনলাইনে।
না, গত ছিল, আর তার আগে দুটোতে অ্যাবসেন্ট ছিল। তুমি রেগুলার অ্যাবসেন্ট থাকো, কারণ কি?
রেগুলার স্যার লাস্ট 2 দিন স্যার এই বাসায় আসলাম তো, আর ফার্স্ট উইকে অ্যাবসেন্ট ছিলাম স্যার, মাঝখানে অ্যাবসেন্ট ছিল না আর।
আচ্ছা, তারপর আর কে বলছিল?
স্যার
স্যার
095
107 মেহেদি
স্যার 095
স্যার 114
না না, তোমরা আবার আসছো কেন? ওয়াই, হোয়াট হ্যাপেন? আমি বলছি তো, আমি যখন অ্যাটেন্ডেন্স দিয়েছি তোমাদের লাস্টে দুইজন বললা, আমি তো আর দিতে পারি না তোমাদের। তো আমি কি তোমাদের অ্যাটেন্ডেন্সের জন্য
095 স্যার
বসে
আমরা
থাকবো? তোমাদের অ্যাটেন্ডেন্সের জন্য বসে থাকবো 10 মিনিট? কি বলো? হাউ ডু ইউ থিঙ্ক? হাউ ডাজ দ্যাট সাউন্ড? হোয়াট ইজ ইওর প্রবলেম?
স্যার
তোমরা রাইট টাইমে তো আমি ছিলাম, আমি তো রাইট টাইমে ছিলাম নাকি ডিলে করেছি? Early এসেছি আমি, বলো।
স্যার
নাকি
আমি হচ্ছে জয়েন করতে
হুম
স্যার
এটা
ক্লাস
কতজনের
নিচ্ছিলেন
প্রবলেম?
তাই তখন বলি নাই স্যার।
তুমি পুরো ক্লাস করেছো কিনা সেটা বলো।
স্যার আমি মানে মানে কিছু মানে একটু পরে জয়েন করছিলাম স্যার।
তোমাদের এই ধরনের করার কথা, মানে তোমরা, আমি এসে বসে আছি, দেখলাম 8 জন, 7 জন, 6 জন, 5 জন, 10 জন। তোমাদের টাইম কি এতই ভ্যালুয়েবল যে তোমরা রিল্যাক্স মুডে আসতেছো? তুমি ক্লাস করবা কি করবে না সেটা তোমার বিষয়, কিন্তু শেষে এসে 5 মিনিটের জন্য তুমি অ্যাটেন্ডেন্স আমাকে দেবে। হোয়াট ইজ দিস? আমি কি তোমার জন্য এখানে বসে আছি যে অ্যাটেন্ডেন্স দেওয়ার জন্য? এটা কি আমার কাজ? হাউ ডাজ দ্যাট সাউন্ড? মানে তোমার একটা অ্যাটেন্ডেন্স আমি তো দিতেই পারি, সেটা সমস্যা না, কিন্তু হাউ ডাজ ইট ওয়ার্ক? তুমি ক্লাস করবে না, জাস্ট অ্যাটেন্ডেন্স নিয়ে চলে গেলা। হুম
পুরো
what is
ক্লাস
this?
করছি স্যার।
কে
স্যার
কে
ক্লাস করছি
কে কে পুরো ক্লাস করেছো সেটা বলো, সেই শুধু বলো আমাকে যে আমি
স্যার
মিস
151
1 মানে 151 বাংলায় বলো।
স্যার 126 আমাদের জন্য অ্যাটেন্ডেন্স দিতে
দাঁড়াও
পারিনি
দাঁড়াও, একজন একজন ক্লিয়ার করো তো।
স্যার।
151 বলছি, আগে 151 বলে এত কথা বলতেছে। 51 কে?
স্যার আমি
হ্যাঁ, শাহিনা খাতুন। তারপর দেখো, তুমি তো অনেক অ্যাবসেন্ট, তুমি তো রেগুলার না স্টুডেন্ট হিসেবে।
স্যার
হ্যাঁ,
95
151, তারপরে তারপর 126,
স্যার 133
দাঁড়াও 126। তুই পুরো ক্লাস করেছো?
জি
জি স্যার, full class করছি।
যোগ দিয়েছিলাম আমি।
হ্যাঁ, তারপরে 126-এ পরে কে?
স্যার
114
তো
স্যার।
এই যে তুমি ক্লাস করেছো
জি স্যার।
স্যার 81 স্যার পুরো ক্লাস করেছে।
রে ভাই
181, কে
জি
কি
স্যার।
না কি নাম?
স্যার ক্লিন্টন রয়।
181 তো নাই এখানে, কোনো 181 বলে কিছু
স্যার
না।
081 স্যার, স্যার 081।
ও 081,
স্যার 95
হ্যাঁ,
স্যার 104
95 হিদা
জি স্যার।
ক্লাস।
স্যার গত ক্লাস
স্যার 98
হ্যাঁ, তারপর
98
স্যার
97,
104
তারপর 90,
8
90 পেয়ে রাকিবুল হাসান, তারপর 133,
স্যার 128
মাহফুজ হাবিব।
104
জি স্যার 133
হ্যাঁ, 133 মাহফুজ বিন হাবিব। তুমি ক্লাস করছো কিনা?
জি স্যার আমি 1:42 যোগ দিয়েছিলাম, একটু লেট হয়েছে স্যার।
হ্যাঁ,
স্যার 128
97 তো আছেই। তুমি কতবার বলতেছো? তোমাকে তো আমি আগে দিয়েছি, তুমি বলছো না?
জি স্যার।
নাইম নাকি এটা?
জি স্যার।
হ্যাঁ, বলছো কেন? তার আবার হ্যাঁ, বলো।
স্যার 104
104, 104 মারুফ আহমেদ। তুমি
জি
ক্লাস
স্যার
করেছো কিনা?
জি স্যার করেছি স্যার
কতটুক?
স্যার আমি 10 মিনিট পরে যোগ দিছি
তারপর আর কে আছে বলো?
স্যার 128 স্যার 10 মিনিট পরে জয়েন করছি
মানে তোমাদের রিল্যাক্সেশনের কারণটা কি? রিলাক্টেন্স, মানে আমি অ্যাটেন্ডেন্স দিই নাকি সব টিচারের ক্ষেত্রে তোমরা এরকমই চেষ্টা করতেছো নাকি? খুব দয়ালু teacher।